Hi everyone, in this video we'll be talking about Gauss-Jordan elimination of the matrix, okay? Matrix multiplication has an important application to systems of linear equation. For example, given the following linear system, okay, we can write this as the one on the right, okay? We call A is a coefficient matrix, and X is the unknown matrix. B is the constant matrix. Then, by using this matrix, we are able to solve X, Y, Z. Okay. Here in the matrix above is called a augmented matrix of the linear system, and it is obtained by adjoining B to A as the last column. Okay. Elementary row operations. In order to solve this linear system, you have to perform row operations to turn the matrix to a reduced row matrix. If the system has only one solution, the reduced row matrix should look like as following: a 3 by 3 coefficient matrix, okay? A 3 by 3 matrix. If the system only have one solution, okay? In order to do that, you have to remember the equivalent row operation. First, interchange of two rows. You can change the second row to the first row, is fine. Second, multiply a row through a non-zero constant, okay? Add a constant times one row to another, okay? These are the rules to do to have the solution. Okay, the procedure of reducing a augmented matrix to reduced row matrix by performing row operations is called Gauss-Jordan elimination. Okay, now we'll give a step-by-step Gauss-Jordan elimination procedure so that you can understand how to do this by yourself. Example 1 from previous final. Solve by using Gauss-Jordan elimination. Here, first step, write down the augmented matrix of the system. -2, -2, 7, 7, 3, -1, 5, 6, 10. Then we have constant number of 3, 9, 21. Okay, performing row operations to get reduced matrix. Okay, first step 1, this is, first step, this is row 1, row 2, row 3. Okay, 1 divided by -2, then we have 1, -3.5, -1.5, 7, 3, -1, 9, 5, 6, 10, 21. Okay, then we use the second column minus 7 times the first column, and then we will have 1, 1, -3.5, -1.5. I'll have a 0. 3 minus 7 is -4. -1 minus 7 times 3.5. This equals 23.5. And then 9 minus 7 times 1.5 negative, okay? So 9 minus 7 times -1.5, which is 19.5. Okay, 5, 6, 10, 21. Okay, then next step is third row minus 5 times 1, which will have 1, 1, 5, -1.5, 0, -4, 23.5, 19.5, and 0. 6 minus 5 times 1, which is 1. 10 minus 25 5 times negative 3.5 is 27.5, and 21 minus 5 times negative 1.5, which is 28.5. Okay. Then the next step is 3 minus 3 plus 1/4 of second row. Okay, then we will have 1, negative 3.5, negative 1.5. Okay, 0, negative 4, minus 4, 23.5, 19.5, 0, and 0. Then 27.5 times, plus 1/4 of 23.5 equals 33.375. Okay, then 28.5 plus 1/4 of 19.5 is 33.375. Okay, then next step is 3 divided by 33.375, which is 1, negative 3.5, negative 1.5, 0, negative 4, 23.5, 19.5, 0, 0, 1, 1. Okay. Now the next step is second row times negative 1/4, which is copy everything down now. 1, second row 23.5 times negative 0.25, which is negative 5.85, and 19.5 times negative 0.25 give us negative 4.875. Looks like I've made a mistake, I think. Minus 1 minus 7 plus 7 times 3.5, 9 minus plus 7 times 1.5, 19.5. Okay. Oh, okay, never mind. It's good. Then we add, so the second row add by 5.85 times the third row will give us 1, 1, there's a 1, 1 here, 1, 1, negative 3.5, negative 1.5, 0, 1, because 0 plus 0 times 5.85 is 0, 1 plus 0 times something is 0, so it's 1. Then this is negative 5.85 plus 5.85 times 1, okay, which is 0. Okay, then negative 4.875 plus 5.85 times 3. I think I made a mistake about this number. Let me recalculate. Actually, I found a mistake. The mistake is not about this number. It's here. You see, so here you really need to be really careful in doing matrix. It is 23.5 divided by times 1/4, which is negative 5.875 instead of 5.85. Okay, 5.875. So here is it's also wrong. It is 2 plus 5.875 times 3. Okay, so it becomes 0, and then negative 4.875 times 1 times 5.875 is 1. Okay, 0, 0, 1, 1. Continue. The next step is the first row minus the second row give us 1, 0, negative 3.5, negative 2.5, 0, 1, 0, 1, 0, 0, 1, 1. Then next step is 1 plus 3.5 times the third row. Okay, this gives us 1, 0, minus 3.5 plus 3.5 times 1 is 0. Then next one is negative 2.5. Sorry. Negative 2.5 plus 3.5 times 1 is 1. Okay, 0, 1, 0, 1, 0, 0, 1, 1. So the final answer is x, y, z, x equal to y equal to z equal to 1. Okay, you need to be really careful in doing the matrix calculation, in doing a Gauss-Jordan elimination, because one simple mistake like it here can make you redo everything. Okay, so be very careful.